Well, hello everyone. Welcome to another Toolbox Tech Talk. Yeah, you haven't come to a live show. It's it is a live show, but it's not a musical show. It's all about tech. It's all about solar and batteries and renewable energy and wind turbines and water and energy management and you name it, all that sort of stuff. So yeah, let me just get out of my shade so I can actually see what I'm doing here. So today's actually going to be, I say this a lot, but it really is one of my favorite subjects, is talking about going off grid. Now, there's definitely a very strong personal connection here. I've lived off grid almost all my adult life, something like 30 years now I've been off grid. I did actually have 2 years where my partner at the time wanted to move to work for government. We had a couple of years in Canberra. That was exciting. Got to see a power bill for the first time in like 20 years. But apart from that little brief interlude, I've lived off grid all my life. So for those of you not familiar with what I do, I run a facility called the Smart Energy Lab here in Melbourne in the Yarra Valley, in the beautiful Yarra Valley. I do a lot of courses. I used to do a lot of face-to-face courses, but these days they're all online. So I deliver a lot of online training. But the Sunday's kind of like my fun thing to do, just talk about stuff and interact with you guys. So first up, I'd like to thank you for attending and being here live with me. And please, if you can hear me, just give us a thumbs up. That just lets me know that it's all working properly. That's always a good thing to know. And also feel free to ask me any questions as we go, because the purpose of doing this live is so that we can interact and I can answer your questions. Now, I've got a few dedicated followers who turn up every Sunday. That's great. And I'd love you just to contribute. So go for it. Ask questions as we go. So what the program for today is I'm going to really just talk about broadly, to start with, what going off grid's all about, and bring some personal experience to that. And then I'm going to go into the different steps that you might consider taking and look at different energy types. So, people think it's all about solar. It's actually about lots of things. And also things like location. How do you manage your comms, your communication when you're off grid? And what about bigger off-grid systems where you can interact with multiple installations? And might even finish up a little bit about, generators and wastewater and food production and all of that. And I guess I should start off with saying that going off-grid actually means different things to different people. People go off-grid for the weekend. They go camping. They may go off-grid in the suburbs. Now, I actually did a live stream for Moreland City Libraries with 3 other guests, and they made the point that there's lots of ways that people go off-grid. They can go off-grid for food production, for wastewater management, for water collection, and they may even choose just to turn off their social media and become off-grid from the internet. Or it may be power and energy, or it may be that they're still connected to a utility, but they're self-sufficient for energy. So all of those things kind of matter. They're all ways that you can think of it as being off-grid. So it's not a single step. In fact, I often say that you can slide off grid. Certainly if you're already on a grid connected home or business, you can actually take more and more of your loads to be self-sufficient and run those independently of the grid operator. So look, I'm going to start with a little picture here. This is where I live, which is Mount Tillybawong. There we are. Beautiful Mount Tillybawong in the Yarra Valley. It's an off-grid community. It's actually 47 years old now. Yep, 47 years old. I've been there for 18 years now. So, it's been my home for a long time. I was off-grid in the New South Wales Wallamai National Park, a place called Weenie Creek for about 15 years prior to that. In fact, a little bit of a backstory to that is I bought a house off the drummer from Men at Work. It was their little getaway house. And actually, it turned out to be the reason I got into off-gridness, because when we bought this house, we didn't actually think much about the power supply. In fact, it didn't have one. It didn't have the grid. It just had a generator and a shed out the back. And I think we were just a bit too excited by this beautiful little house in the Wallamai National Park, 4 kilometres with inside the park, nowhere near any neighbours, etc., that we didn't give it much thought. And that's what got me interested in renewable energy as a way of living off-grid, because running a generator, for those who've done it, on a permanent basis is a nightmare of noise, cost, inconvenience, reliability. It's just all pretty bad. Yeah, so that's this is where I live. And what are the reasons that people choose to say, in terms of off-gridness being not connected to the utility grid, why do people choose this? Now, I mean, there's lots of reasons. You couldn't actually be moving to an area like I did where there was no grid power. So that can be one of the motivating factors, is that you just don't have a choice. You basically don't have any power. But I always say that one of the first things, because I used to run a business installing solar, that you should do is actually find out what it costs to get connected. Now, don't rule out that the grid actually can be a cheaper option. So investigate that. But what's really interesting is the cost of connection, certainly in my area, now is competitive with a modest off-grid system. So if you're in what they call a greenfield site, basically, you're building a new house on an empty vacant block, there may be power in the street, it may be 200 meters from the house because it's a rural property. Just the cost of getting the power to your house can be similar to building an off-grid system. So it's become very, very doable. Yeah, I got a comment coming here from, let's have a look at this one. Thanks for the thumbs up, people. Yeah, Tradie Trev, you'll have to pry YouTube out of my cold, dead hands before I'm going off grid. I hear Elon is letting Aussies use his Starlink now. Yeah. Actually, Tradie Trev, we actually will come back to communication towards the end of today, because it is one of those things as part of off-gridness, is how do you maintain connection. And Ray points out, thanks Ray, you're one of my regulars too, that in a Victron video from the UK, the cost they quoted was £70,000 to £120,000. Now, that is a question that I used to get all the time, is how much does it cost to build an off-grid system? Let me hit you up with that one first up. It really is as long as a piece of string, and you'll see some very modest systems that are nowhere near that price. But of course, they're limited in their capacity. So it really comes down to what you need. And we're going to go through that and look at some of these shortcuts and some of the savings that you can make in that process. Anyway, coming back to why do people choose to go off grid, it can be things like a tree change. They would choose to leave the city, which is happening apparently a lot more since COVID, certainly in Australia. A lot of people are choosing to live in rural and regional areas, and so they may be in areas where there isn't grid supply. It can be ideological. For instance, people choosing to go off grid even in the city where there is the grid. I mean, I've been involved in taking a couple of houses off the grid. That is quite a big thing to do, not in terms of how difficult, but in terms of cost. So you're choosing not to pay a few $100s a quarter for a power bill, instead pay $30,000, $40,000 not to have a power bill. It's hard to justify that sort of expenditure. You probably never recoup the savings in that, but it's an ideological position. So some people actually want to have nothing to do with the utility grid. Then you've got the preppers preparing for the end. Now, I used to joke about that, but actually, haven't we had a bit of a prepper moment the last year or so? And people are looking at self-reliance a lot more. So whether you're on-grid or off-grid, actually being able to supply energy in the case of a loss of grid power, or the case of you're completely separate from the grid, is part of that resilience. Now, resilience actually is really an important part of design in a off-grid system, and I'll talk more about that. Yeah, so got a few more little pics here to show you too. So let me just bring this one up. Yeah, so this is my little house and my neighbour's house. My house is the sunny one there in the middle. It's a modest-sized house by Australian standards, 160 square metres. It's 2 stories. I'm in that office upstairs right now, waving out the window at you. See me? Yeah, there we go. And I've got about 10 kilowatts of solar perched on my roof. But actually, the buildings behind my house to the top of the picture are actually my labs. And this is a fairly old picture. We've put in a lot more solar. We've got about 100 kilowatts actually connected to the houses that you can see there via what's called a microgrid. So we share energy between houses. And I'll talk a bit more about that further down the track. Yeah, so thanks, Ray, for sending some links. So I'll leave those for people to look at after the show. That's great. Good to do your research. And got one more slide here. Where are we? Oops, gone too far. Yeah, so that's that's where I live, and this is my neighbour. Now, that's my neighbour's system. That's really quite a small system. That's known as an e-store, and you could even describe that as not an off-grid system at all. It's designed as an on-grid hybrid system. But what's interesting is that when you can utilise a sort of self-generated grid, which is what we have here, a microgrid amongst 7 homes, you can install relatively small, modest systems and still get by. So she would be leaning on the microgrid in wintertime quite often, but she's got 10 kilowatt hours of storage there and a 5 kilowatt inverter. That's a modest system, but it's, you can see she's not very tall, and it's quite a small system there, but she has a lot of solar. Now, in fact, that's one of the secret weapons these days, is to put in a lot of solar, because solar's become so affordable, and it still gains generous rebates or through the certificate system, even when you're off grid. So there's no difference between on grid or off grid in terms of the federal rebates. You still get them, and that means putting in lots of solar actually helps reduce the cost of everything else. So she's got about 3.5, let me think. Yeah, about 3.5 kilowatts of solar on her roof, and she's a very efficient energy user. I think she uses about 4 to 5 kilowatt hours a day, so she has ample in summertime, and that small system is quite big enough. So that's not a 70 to 120,000 pound UK pound system. That's more like, a $10,000 plus system, maybe 15 with the solar and the solar edge inverter as well. So yeah, that's quite a modest system, but she does rely on a backup. So the fact that there is a generator sitting behind that. So one of the first things that you need to consider when building or when designing an off-grid system is actually what the purpose is. Now, this picture, you might seem a bit weird. I'm showing you this. This is a toilet block in the Northern Territories. And it's about an hour and a half from Alice Springs. Now, I used to do inspections for government authorities, and this is one of the ones I looked at. And actually, I gave this an award for the installer, an award here for the best installed off-grid system I'd seen. This was over 10 years ago, maybe 12 years ago. But it highlights a really interesting problem, which is that cost $120,000. And that was over 10 years ago. And what does it provide? It provides 2 lights and a couple of flushing toilets in men's and women's sections for about a dozen people at peak time of the year per day. So it's got a very modest requirement, and it cost $120,000. In fact, I'll tell you more, it cost a lot more than that after the second time round. But anyway, the first time round, the design brief was the problem. So when you're looking at building, for instance, an energy storage system and a solar array to go with it, think about what you're trying to produce that energy for. In this case, if the outcome was to have toilets and lights, there were much, much cheaper options. But no, they went for flush toilets in the driest part of Australia, lights, which probably don't get used because it's people only get picked up at the end of a walk and then just hop on a bus. And because there's no water here, because it only rains about twice a year, they have to truck water out. You can see the truck in the background there. Also, it has a pump-out toilet system, so they've got to pump the wastewater out, so another truck has to come and pump it out. It's a lot of work, a lot of cost for what really could have been done with a little solar kit from Bunnings for about $50, just clipped onto the gutter with a light on the end of it, and a composting toilet, because in the driest, hottest parts of Australia, composting toilets are a no-brainer. They just work amazingly well. So yeah, I kind of use this one just to give an example of why it matters that you consider what your objective is. Don't just start with, let's build a great big solar and battery system and it'll run everything. So the cost thing, this is kind of a starting point for many discussions when people are choosing to go off grid, is how much is it going to cost me? And I've got a kind of little strategy that I use here. Let me just bring up my drawing tablet. So there's kind of three approaches. One is size and cost of off-grid. So what are the factors? Well, the best way to size an off-grid system is to do it for the load requirements. So the load energy requirements. And that means you've got to do a load assessment. You've got to find out what you're trying to run, how long you're trying to run it for, and as I've done in previous Toolbox Tech Talks, do the calculations to find out what that load energy requirement is. And then you build the system to meet that load energy requirement. So that's actually the best approach. But approach number 2 is a pre-built system. So that means that someone is offering for a price a certain size system. For instance, it might be, e.g., 15 kilowatt hour battery and let's call it 8 kilowatts of PV. That might be equals X dollars, whatever. And so you're really doing what many people do when they buy an appliance, is just make a informed choice, or even a poorly informed choice, and buy a system for a certain price and hope that it works. Now, when I say buy a system, it's going to be installed by a professional. These things aren't something you put on the back of a caravan if it's running a home. Sorry, there's actually some more chats coming in here. Totally agree. The KISS principle, keep it simple, stupid, is really where it's at when it comes to designing a off-grid system, cost-wise and reliability. So yeah, thanks for that one. But number 3 is actually where most people end up, which is budget. And so, we've got approximately, X $1,000. What can we get for our money? And so you might start with, this is what you want to build a system for, but then you end up down at number 3, which is, this is my budget, which means you may have to revisit 1, go back to 1 and sort of scale everything down a bit. That's if reliability is important. Now, there is a standard for designing off-grid systems, and it's ASNZS 4509 Part 2. And it was published in 2009. It's actually still a very relevant standard, and I've done Toolbox Tech Talks on it. And it basically takes the premise that you want a system that is reliable and provides a large solar fraction. So it's really focused pretty much on solar, though you can substitute renewable energy, solar energy, for other forms of renewables, which will actually come to my next point. So my next point really is, it's pretty important to think about what your energy sources are available to you. Now, people automatically think solar when they think about going off-grid, but actually there's other options, and you should look at the resources available on the site. Now, for instance, there may be a reasonable wind resource, and I'll put some caveats around that in a minute. There may be a mountain with a creek flowing down it. There may be a very powerful stream flowing past you. So there's water, energy source. There may be abundant renewable sources of wood. You may actually grow it yourself, so you've got a biomass option, or you may even make biogas. So there are other ways of generating energy. So looking at those resources first. Now, having said those, it still generally comes back to solar, and the reason for that is cost, and the fact it's so reliable in terms of the sun comes up every day, even when it's raining, the sun is still there. It's just at a low intensity. So the reliability factor of solar is so strong that it's a very good first choice. Wind and hydro are very site specific, so you want to look very carefully at those options. They do have some advantages over solar in some regards. For instance, wind actually can generate at nighttime if it's windy at nighttime, so it can cover parts of the day when solar can't, but then again, it may not be windy, so you can't rely on it 100%, but that's where a wind analysis comes in. And parts of Victoria, where I live, actually have some of the best wind resources in Australia. Certainly near the Southern Ocean, there's some wonderful wind resources in those locations. But the other issue you need to consider, and if we've got any wind people on here, they'll be jumping up and down to tell me this, is you've got to consider the microsighting. It's all about how big a wind shadow that nearby objects cast. So it's actually quite difficult to get good laminar flow, and you need to be up high. So if you're in a forest, rule it out. even if you're in open paddocks, but there is a wall of trees 40, 50 meters away, on the dominant wind side, on the prevailing wind side, that can pretty much disturb the wind sufficiently to make it a poor wind site. So wind does require a lot more site assessment. Hydro is very cheap if you have the option. Now, here at a Smart Energy Lab, in fact, on the co-op that I live, Murumura Co-op, we've got all three. We've got wind, micro hydro, and lots of solar. The microhydro actually works amazingly well, but it's a very small system. It provides backup power for about 6 houses, and it's lucky that we have a spring on top of our mountain, and the water flows down about 90 vertical meters in height difference to a turbine and generates a small amount of power to provide some trickle charging to some about 6 houses. So, but that's very unusual to have a site like that. So once again, it's very site specific. All right, so coming back to some of your first steps when going off grid is to think about reliability of your energy source. Now, like I said, solar is very reliable, but there are other options for some of the other services that you might need. Now, one of the ones I generally focus on is water. Now, if you need to have water for flushing toilets, for drinking, for washing, you're going to need it at pressure. So generally that means you have a pressure pump, or you pump water and store it in a header tank and then remember to pump it back up again when it's emptied. I've lived on a house like that where it usually ran out from the header tank in the middle of a shower with the soap in my hair, and I had to run outside and turn the pump on and wait for it to fill up the header tank again. That was a fairly unreliable system. But if you've got a pressure pump, now there are many choices in that area connected to a tank which is at ground level that can provide you with the equivalent of mains pressure water. But you are relying on electricity to run that pump. So from a resilience point of view, if you have options for storing water at height that you can use whenever without having to run a pump, that's a really nice sort of level of resilience in the design of the system. So what we've got here on my cluster, I'll bring my drawing picture back, is here's my house, and there's a slope that goes down and then there's a slope that goes up. And so what we've done is put a large 35,000 litre sump tank here. And so water will flow off the roof down into this sump tank whenever it rains. In fact, it's not just my roof, it's my neighbours as well. There's, I think, 5 roofs flow into this 35,000 litre sump tank. We then have a pump connected to that. So we've got a pump here. That's our pump, and it pumps water up the hill to a very large storage tank. So we've got 260,000 litre tank up the hill, and the height difference here is 20 metres. Now, what does that mean? And by the way, this isn't complicated. If you live on a rural property and you've got space to run pipes, it's actually quite a cheap thing to do. This tank, I think, did cost us about $12,000. It's one of those on ground with a bladder in the middle, corrugated iron tank. It's about 14 metres in diameter. But what it's able to do is this water, which fills up in the sump tank every time it rains, is pumped using solar energy, surplus solar energy. So one of the things about a solar system when it's off grid is once your batteries are full, you can't do anything with the energy. You've got to use it or lose it. So what we do is we use it to pump water. So effectively pumping water out of the sump tank and storing it in a header tank is like making a bigger battery. We're storing energy at altitude up here. And so when you turn on a tap, we have a return pipe. So that's the flow pipe that's pumping uphill. We have return pipes that come back down to the houses. So there's the return here this way, and that's going to provide us with modest pressure. So 20 metres of head after pipe losses around about 1.6 bar. Mains pressure is around about 3.5 to 4 bar. So it's not full mains pressure. So we still have a booster pump at the end there. But if we lose power, we still actually have water. You can have a slower shower, a slower filling of your, dishwashing machine, but it still works. It's not like you've lost all water sources. So we're doing two things with the design. We're finding a way to use surplus solar and pumping water with it, and storing that as energy. And we're creating a more resilient system so that in case of electrical failure, we still have water, because that's one of the key services in a home or business, is that you have water. And certainly if you're in a bushfire prone area, that having water that you can bank on, because it's just a pipe underground. That's a real plus. So just coming back to the general points I wanted to make. So far that's about resilience. The other thing that I say you really need to focus on when you're looking at going off-grid is appliance selection. Now, you may already have appliances and you want to take them with you, or let's say you're an on-grid home that you want to disconnect, which is pretty unusual, but you might want to. The appliances that you have are going to be the cost that you have to face to run them, the cost to build a system to run them. And I like to kind of give some sort of ballpark figures to people when we talk about how much does an off-grid system cost. One easy way I find to explain is it's all about the energy requirement. So I have a kind of a ready reckoner that I use based on my costs for building a system of something like $2,000 to $4,000 per kilowatt hour per day of energy requirement. Now, you're looking at that number and thinking, what? That sounds like a very, very expensive system. So I call it the system build estimate. And the reason for that range, by the way, is all about how big a battery bank you have. Therefore, how many days without renewable energy input can you operate the loads for? So at this end of the spectrum, we'd be looking at 2 days of backup, and at this end, maybe 5 days of backup. And that's really a design decision, how many days of backup that you want to have. So do you actually want to have to run a generator at the moment the sun doesn't come out in the morning? Or do you want to be able to ride through a rainy period and then recharge after the rainy period or the inclement weather has finished? And so this gives you a rough idea. Now, this kilowatt hour figure here is your energy requirement, and that's where it comes back to appliances. Let's just give a simple example. You've got a beautiful fridge. You've had it for 10 years. It works perfectly well. You don't want to waste it, throw it away. But when you look at the energy rating, and let's say it's 15 years old, star ratings of appliances have improved a lot. And also they've increased the number of stars on the star rating scheme here in Australia and New Zealand. So let's say it's a 600 litre fridge, and it uses 2.5 kilowatt hours per day. Now, that's not unusual for a fridge of about 15 years old. Let me just zoom in a bit on that. So that's what you've got. How much would it cost to build a system to run this fridge? It's going to be that times that to that times that. So somewhere between about $5,000 and $10,000 of system build price to run that fridge. Now, you might think that's ridiculous, but it's not. It's not at all, because a fridge is actually one of those appliances that from the day you buy it, you generally never turn it off again. It's not a discretionary appliance. You don't go, it's a bit overcast today. I think I'll just turn the fridge off for a day or so. No, because you'll lose your food. So that's an expense as well. So let's say we replace this with a modern fridge of the same size, and so we can look up. So this is a new fridge, and it uses 1 kilowatt hour per day. Now that would be a very efficient fridge, by the way. It would be like your 6-star fridge, which is probably going to be expensive. Probably going to be, I don't know, $2,500 or something. You're going to go, ooh, do I really want to spend $2,500 on a new fridge when I've got a perfectly good old fridge? But let's look what it's done to our system build price. Our system build price now has dropped to $2,500 to $5,000. So you could say, Compared to here, we've actually saved $2,500 at the low end just by buying a new fridge, which is probably the purchase price of the fridge. So energy efficiency saves you money from day one. It's just a no-brainer. You really have to look at energy efficiency as your first source of energy, because it's the negawatts, the watts you never needed are the watts that matter. So that's a kind of just a ready reckoner. So I'll bring it back up again for just costing a system build. And I say it really drives people to think about how to trim that number, trim that kilowatt hour figure down by appliance selection, but also by the way you use things. I mean, if you're used to living on grid, and you happen to remember days when electricity was cheap, you may have got used to not turning stuff off. And, things like lights, unwatched televisions, entertainment consoles that are always on. Sometimes it's the small things that are always on that you don't even notice that are using power. All of those things are personal choices that you can use to reduce your energy demand. So there you go. Those are some of the first steps, is look closely at your appliance selection and how you can make a more efficient installation. All right, now let's look at, we talked a bit about resource assessment. Actually, just remembering I had some pictures to go with that actually. Here's a nice one. This is actually a water pump here at our co-op, which is about 35 years old, I think, and it's known as a water ram. So it pumps water using water. It's a water-powered pump. It's nothing fancy. Really, what happens is water flowing down a short pipe of about 5 meters long, is interrupted by a valve that closes due to gravity, and it causes a pressure pulse, which pumps some of the water back up the hill to a head of about 40 meters above into a storage tank. And so the result is something that just goes dink, dink, dink. It's a little bit noisy. You don't want it next to your house. And it pumps water. And I think we've replaced the moving part on this once in that 35-year period. So there you go. If you have abundant supply of water, using water to pump water is actually a very easy option. So there's an example of resource assessment. I didn't even need to run power to this site, which is quite a long way from where anyone is, so it would have been expensive to put in pumping. Though ironically, we have actually run power down here because we wanted more water. But there you go. There's an example of resource assessment and how you can manage that. All right, so I'm just looking at the questions here. Okay, so Ray, thanks. Would you do more solar to battery ratio or more battery to solar? Always more solar. There's kind of a fake sense of having a lot of capacity when you have a very big battery bank, because as soon as it's empty, you have no capacity at all. It's all about filling it up. And the bigger the solar array connected to that battery, the less you need to use the battery, particularly during daylight hours. I often say if you can size a solar array so that you use no battery energy during the day and it's all coming from solar and there's enough surplus to recharge the battery, then you're really only sizing your batteries for nighttime loads. So yeah, that's definitely the way to go, is lots of solar. I have a flippant term. I say that the answer is always more solar panels, and that's become true, really is. Partly because of price, but also it helps offset other components in the system. Covering a house with solar panels, as you saw in the picture of my place, actually helps keep it cool. So there's very little exposure to direct sunlight on my house. So that's actually a benefit too, just having all those panels covering almost all the roof. By the way, that picture's middle of winter when it's frosty. But yeah, in summertime, there's very little direct solar radiation. So that's another plus. But it actually helps reduce the cost of the components, which are still very expensive when you're going off grid, which is batteries. So I should make the point too, is there is a little bit of a misconception that off-grid has become very cheap because on-grid solar has become very cheap. Well, I wouldn't quite go that far. It's become cheaper, but still the big difference is not just the fact that you need batteries off-grid. but actually you need a lot of it. When you're on grid with batteries, it's kind of a feel-good thing. It just provides you with a way of using surplus energy, that at nighttime, after the sun's gone down, it's not essential. But when you're off-grid, it really is essential. And I sometimes refer to a thing called Maslow's hierarchy of needs. I'm just going to bring this one up for you. So Maslow, a psychologist, I think, who came up with this idea, is that we have some base needs which are really important. And let's say, as a human, air is pretty important. So without air, we wouldn't last very long. Water is pretty important. Then we need to sustain our energy levels, so we need food. We need comfort, though how much comfort is a personal choice. We need things like socialization. We are social creatures, and etc. It goes right up to self-actualization. So whatever that is. So there you go. So that's the hierarchy of needs. Now, if I apply to this an off-grid system in terms of its energy services, if your off-grid system fails and you have no electricity, can you still breathe? Yep, you can still breathe. Okay, so we've got a smiley face there. So no problem there. What about, have you still got water? Well, if you've got a pressure pump, no. So looking a bit sad there. So if you've got a pressure pump, you've got no water. If the power's gone off for a significant period of time, you may lose all of your food in the fridge. And if it happens to be hot or cold and you've got no way of regulating temperature, such as fans or thermal pumping systems, you may be very uncomfortable, and your friends don't come around anymore because it's not a very nice place to be, and you probably don't meditate very much or become self-actualized. So there you go. It really makes a huge difference when you're off-grid, the importance of reliability of energy services. So there you go. Maslow's hierarchy of needs kind of twisted a little bit. So yeah, now what have we got here? Got some more questions. Trev says, they are cool. How do they work? Where's the vid? Thanks, Tradie Trev. Actually, maybe I'll go down to it next week and film it working. It's a little bit messy, actually. When you take the splash cover off, you've got to stand back a bit. There's a fair bit of water flowing around. But yeah, it's super simple. So I'll do something for you there. Tradie Trev once again says, where's the bloke who was using his excess energy for Bitcoin? He's now the guy is living in the future. So, yeah. Are you referring to me, Tradie Trev? Because I did do a Toolbox Tech Talk on mining cryptocurrency with renewable energy. In fact, I got my little miner running right now out in the shed. Really, it's just soaking up surplus energy, which otherwise wouldn't be produced. So there you go. Kind of fun. And, Gerhard. Sorry. There's a dialog box hiding. Sorry. Can you shift the dialog box all the way down as it hides the bottom of your paper? Sorry, I didn't realize that. So let me just cut over to that and hide the dialog box. So there you go. You should be able, I can see it all. So I'm not sure if you've got a dialog box popping up there or not. Yeah, where was I? So yeah, I was talking about understanding resources and things like, do you have a solar resource? Well, we probably do if you can see the sky. Do you have a suitable wind site? Well, you probably want to do a site assessment from someone who understands wind. Can you use water as a way of generating power? Well, if you do have a water resource, and there's often planning issues associated with that, for instance, diverting water may not be permitted, even if it's a small amount. So even though you're just borrowing the kinetic energy, it's still going to change the flow for part of that water system. And do you have a source of biomass? Now, I've actually got a steam engine here at the lab, which we still haven't commissioned after 15 years. It uses wood to to make high pressure steam and to run a steam engine. So there's a biomass generator, but it's a pretty unusual option. I did actually sell one to a neighbour across the road who absolutely loves it, I'm told. It's even been on telly a few times. So there you go. There are many options for resources for energy production, and you should consider those. So just looking at questions here. Oh, great. So we got from Tom, can a massive PV charge a small battery system on a really dark day? So don't need a big battery system. Yes, and but. So there's a yes and a but there. So the maximum charge rate of your battery still will be a limiting factor. So if your battery can only charge at, let's say, 3 kilowatts and you have a 100 kilowatt system, it's just not going to push all that power into that battery. That's an extreme example. So, but the thing is, when I say you've got a very big system, let's use a more reasonable number. Let's say you have a 10 kilowatt solar PV system. It's only 10 kilowatts. Well, it's almost never full power because it loses power due to temperature, which I've done other Toolbox Tech Talks on, explaining all the losses in a PV system, but most notably on overcast days due to low irradiance. So a 10 kilowatt system on an overcast day might be producing 5 to 10% of its power. Well, that would be rain probably. So you're down to like 1 to 2 kilowatts. That's still useful. So oversizing means that even during poor weather conditions, you've got enough capacity to cover the loads in during the day and still charge your battery. So there is definitely a benefit for having more PV than you need, just to offset your need for energy storage. So thanks for that one, Tom, sorry. And David, love the suggestion for selling a yearly maintenance plan to check system and check battery use and sell more lithium when needed. Now, g'day, David. It's good to have you on. David's pointing out that some battery types are modular. Now, lithium-ion batteries are modular batteries. That means they have the ability to be managed as separate modules from each other. And one of the big advantages with that is that you can add more battery modules as required. It does depend a little bit on the type, but those designed for off-grid applications often are very modular. Now here at the Smart Energy Lab, we've got a stack of Power Plus Energy batteries, got 20 of them. I could have started with one and just added one at a time until I filled up the cabinet. So each battery adds another 4 kilowatt hours of storage. Now that's a modular system. But contrast that with a typical lead-acid system. Generally, you will build a lead-acid system as a single string of battery cells, and you will design it for the job it has to do, and then it will last, hopefully, 10 or more years, and then you'll replace it. It's not very practical to upgrade an existing lead-acid system. You really have to use it and replace it. Whereas a modular system allows you to start small and grow bigger, which is really good if you're a bit strapped on cash at the beginning of the process. G'day, Louis. Good to have you on the show too. Louis says, at the moment, I get 66 cents feed-in tariff, not particularly financially practical. Got this back. He'll have this to 2023. What do you think? Very few blackouts. Yeah, good point. So actually, going off-grid's not for everyone, and putting in battery storage is not for everyone. In fact, I'd even suggest it's not that financially viable without government assistance at the moment if you're on-grid, because really more solar is probably a cheaper option. But to point out something, Louis, it is possible, even when you're on a feed-in tariff, to add more solar and more batteries as long as you don't parallel with the existing grid system. So that means you put in a separate off-grid system within your on-grid home. There's nothing dodgy about it. As long as you're not interacting with the utility grid, then it's a separate system and doesn't have any impact on your feed-in tariff. I did actually do a Toolbox Tech Talk on this. It's called the Death Spiral Accelerator, ways that people can add more solar and storage without being limited by utility rules or feed-in tariff regulations. Okay, so Dennis, thank you, Dennis. So what's Dennis asks, including small-scale wind, 100 to 300 watts can help keep the lights on when the sun is off. Absolutely, Dennis. I've actually got a small 200-watt turbine on my lab here. I like to think of it as more of a wind ornament than a wind generator, because it really is pretty small, 200 watts. But you're right, there's some niche applications, particularly on boats, for instance, where a wind turbine can keep the batteries charged when no one's using the boat, for instance. But at that sort of scale, you could argue that if that wasn't the advantage, that it's on a boat where it's got good wind access, just a single solar panel would probably produce as much. So yeah, wind still has a role to play. Okay, Ray's asking, I'm loving all these questions today. Thanks again, Ray. Inverting to 240 volts or 408 volts for three-phase. What do you think the battery bank voltage, 48 or 72? Okay, so getting really technical now, down to battery bank voltages. Now, I think this is more in the realms of the installer, make those decisions or offer suggestions, but higher battery voltages generally associated with higher power equipment, and also the particular choices that you have. Now, 48 volts for off-grid has become very popular for a long time because it's a nice balance between current, the maximum current that you're going to be drawing out of a battery, and the power rating of inverters that you can connect to a 48 volt system. But for very large systems, generally they go much higher, 120 volt being a popular next step, and 400 and upwards for really large systems. So there's a lot of factors in what is the right battery voltage, but it is possible to generate almost any AC voltage from almost any battery voltage. But Ray, you've got me on one of my favorites to point out is why, say, a 12 volt system may not be suitable for an off-grid home. Now, let's cut over to my drawing again, and where are we? Running out of bits of paper here. Oh, let's get a fresh bit. All right, so sorry for drawing on the back of another piece of paper, but it went rather fast here. If you've got an inverter that draws 5,000 watts, and that inverter is running off a 12 volt battery, Ohm's law will tell us the current that you need to draw is 5,000 divided by 12. So here we go, 5,000 divided by 12 equals 416 amps approximately. Now, if you're not familiar with amps, that's a lot of amps. 416 amps is a very big cable just to run a 5,000 watt inverter. But that's not true, because generally a battery will droop in voltage under load. So a 12 volt battery is not actually 12 volts all the time. It'll be higher than that when it's fully charged, but as soon as you put a massive load on it, it'll droop. And how much it droops depends on its size. So it wouldn't be unusual for it to droop down to like 10.5 volts. So now the actual current draw is going to be more like 5,000 watts divided by 10.5 volts is nearly 500 amps. So there we go, 476 amps. So that's what happens when you've got a relatively low battery voltage trying to generate a modest amount of power. Now, if you double the battery voltage, you halve the current. So if you go to a 24 volt system, then it's 208 amps, or in the case of full load, 230 something. If you go to 48 volts, you halve it again, so it's 100 and something amps. And now you're into much more comfortable territory in terms of cable size and the size of your protection devices. So that's why really 12 volts much better suited to things like recreational vehicles, because that's what the vehicle battery is. 24 volts is the beginning of like your small cottage kind of sized system. But once you get to 48 volts, your options really open out. There's a lot of choices in the 48 volt area. Yeah, so looking, oh gosh, there's more questions coming in. Great. So this one's from Lindy. Lindy asks, do you mean it's not very practical or possible to add more panels into a system with lead acid batteries? Actually, the reverse. It's not very. It's very easy to add more solar generally, but it's not easy to add more batteries. So that's the problem, Lindy. It's not the solar. It's the batteries. So maybe I need to explain this one too. why is it difficult to add more batteries to a lead acid system? It's kind of to do with the way lead acid works. And a lead acid battery is what's known as an unmanaged battery. So if I draw a string of cells, and we'll call this our 48 volt battery bank, but actually it's made up of, consists of 24 times 2 volt cells. So there's your typical 48 volt lead acid. So it's a lead acid system, right? Now, that might be the initial design you built, but then you want to add some more batteries. You can't just add, 2 more cells. You've got to add another 24. So let's say you add another 24, because they've got to be the same voltage, and you join them together. Now that looks all very good. So you've got another 24 2-volt cells. But the problem is, because these are unmanaged batteries, the amount, when you're charging them from one position, from one conductor. So that conductor there, sorry, bring it on screen. Actually, I'll just zoom out a little bit. That conductor there is your charge current, okay? And it's going to go between the 2 strings and flow into them to charge them. But how much goes into string A and how much goes into string B depends on what's known as the impedance of the strings. Now, with a lead acid battery, as it ages, its internal resistance increases, and therefore it'll accept less charge. So it'll slow down the rate of charge. So that means if this is our old string and this is our new string, the new string will get charged quickly and the old string will not get fully charged. So that exacerbates the aging of the old string. That means it's not being fully charged, and therefore the impedance goes up, and therefore that's a self-reinforcing loop, and so it quickly deteriorates. It actually is bad for the new string as well, because it gets slightly overcharged all the time. So you end up, if you combine old and new batteries in parallel with lead acid, you're in trouble. But it's not the same with managed batteries. Now, lithium isn't the only type of managed battery, but they actually have electronics which balance all those cells inside them to maintain an equal amount of current in each of the parallel modules. So it's much more practical to do this with a managed battery like a lithium ion. So I hope that makes some sense, Linda. Louis points out, adding a battery system may have compliance issues. Now, I think I know what you mean here, Louis. So in Australia and New Zealand, our standards generally say that if you are changing the power, voltage or topology of a system, you need to bring it up to current standards. Now, if you add more battery capacity, you may trigger the requirement to upgrade that system to the current standards. Now, Lindy, your system might be, more than a few years old. We actually introduced a new battery standard just last year. Actually, the year before now. Oh, that went quickly. So a couple of years ago, we introduced a new battery standard, and it really upped the ante in terms of a lot of compliance requirements. So it could mean that you can't have it in the location it is currently, because there are a lot of location restrictions, like not inhabitable rooms. All of your protection gear might have to change, like your overcurrent protection and your isolation. So it ends up being very expensive because of compliance. So yeah, thanks for that one, Louis. Tom says, can a programmable lead acid charger be used to charge lithium batteries? Be very wary of charging lithium batteries with anything but something designed for them. They are not tolerant of overcharge. They will often go into thermal runaway and cause a fire. So I would not give any advice on using any old charger with a lithium battery. You need to use one that's designed for the particular chemistry. So lithium batteries aren't generic either. There's all different types with different voltage requirements. And they're actually kind of like a high performance, race car. They've just got to be driven very spot on. Like they can deliver a lot of power, but they can easily be overcharged or charged when they're too cold, just as bad, or too deeply discharged and then try to be recharged, which is bad. So they've got a lot of conditions that they have to maintain to be safe. Thanks, Lindy. Here's another question. I don't want to add the battery bank, just add more panels, so that's all good. Yep, totally. I'm glad we cleared that one up, Lindy. And you probably want to talk to your installer about how best to do that, and that may come down to something we're about to talk about, which is AC coupling and DC coupling. Boy, I've been going for an hour. I just realised this might actually have to be a two-part Toolbox Tech Talk, but we'll just move on a little bit here, and really appreciate the questions coming in. So that's just it's great to have. WW says, if I had 100 metre of height and two 30,000 water tanks, what size pump and what diameter water pipe would you suggest, please? I'm not quite sure. Are you meaning to run hydro? I don't recommend trying to run pumped hydro, which is where you pump water up the hill, run it back down again to generate electricity, because the volume of water use is insane. Just to give an example there, our little hydro system, which has 90 metres of head, the more head you have, the better, because pressure is better than volume in terms of generating electricity. We use 110,000 litres a day to generate 6 kilowatt hours. That's a tiny amount of energy for 110,000 litres of water a day. But because the water's flowing anyway, it doesn't really matter. But if you had to pump that water up the hill, 110,000 litres every day, to generate 6 kilowatt hours, it just doesn't make sense. Pumped hydro does work at scale. When you're talking like the snowy, 2.0 kind of scale, it totally works, but not on a small scale. David says, I was just about to ask as your preference on AC or DC coupling, but I guess you're about to go over that soon. Yeah, look, I just need a piece of paper. Hang on a second. I just realised I'm running out of paper to draw on. Okay, back with you. Yeah, so AC and DC coupling. Now, I have covered this in other Toolbox Tech Talks, and for those who are new to my channel, what I do is after this session's finished, I'll then re-edit this live, cut out the beginning where I'm dancing and grooving away while I'm waiting for the stream to start, and then put in chapter markers so you can go to different parts of it quickly. But also I put in some what they call cards, those little links that appear up here. They won't now, but they will in the edited version, which I'll probably release tomorrow. And that will link to some of my other Toolbox Tech Talks and other training videos that I've made. So, or you can just go to my channel, so Smart Energy Lab. If you go to YouTube and just search for Smart Energy Lab, you'll find a lot of content there. But anyway, that's just how I develop things. So AC and DC coupling, I think we're up to that now. We are indeed. I've got a little notebook here, stuff I need to cover. So Lindy, I'm not sure if you know what type of solar connection to batteries you currently have. Do you have a solar inverter, or do you have a charge controller, for instance, something that is quite a small little box? It's what's known as a DC-DC maximum power point tracking charge controller, as opposed to a solar inverter. Those are the two basic ways that you can put energy into a battery, and there's pros and cons with both. And so to answer David's question, let's do a drawing. So and by the way, the word coupling is how does the energy get from the solar panel to the battery? If it goes through DC cables all the way, it's DC coupled. But we need something in the middle here. And this device here is a maximum power point tracking charge controller. Now, there are other simpler ones, which I've also done a Toolbox Tech Talk on, called pulse width modulation. But if you're talking larger systems, I should zoom in on that a little bit more for you. If you're talking larger systems, really the efficiency gains of a maximum power point tracker are significant, and you really do want to use those. So I'll get my screen the right size for you. Here we go. So that's DC coupling. The advantage of DC coupling is it's a dedicated way of charging that battery. It doesn't rely on any other components, so you don't have to have your battery inverter working to accept the charge. It will do it very, very efficiently, and also it's relatively easy to add more. So there's nothing stopping me adding another MPPT. Now, generally, I'd want to use a product that can work in parallel with multiples of itself. So they'll have often a little comms cable between them like this, which means that they work in unison. So that's quite a nice thing. So adding more solar, Lindy, often will mean unless there's spare capacity on your existing charge controller, you probably add another one. But AC coupling is a bit different. AC coupling is where you actually use an inverter to send power to your battery through the battery inverter. So AC coupling is a bit like a on-grid system. So what we have here is a solar inverter that takes DC and makes AC. So I'll call this a solar inverter. And the solar inverter then will convert that DC to AC and supply the switchboard on your home. So this is your switchboard. That's your switchboard and provide power to your home. But it won't work unless at night time, unless you either have the grid or you have a battery inverter as well. So what we add off the other side, it's also AC. So the red lines are AC, is a battery inverter. So there's my battery. There's my battery inverter. Let's move that a little bit so you can see it. And so if you have a system like this, you can still add more solar, but you're going to probably, unless you have spare capacity on your solar inverter, have to add another solar inverter. Now you might think, well, Glenn, that's exactly the same issue as with DC coupling. But the difference is that solar inverters generally are bigger and somewhat more expensive than the humble DC coupled system. So these are often per kilowatt quite cheap. So you can get quite powerful DC coupled charge controllers that can charge at quite a high power rate. So yes, you can add with either type of system, whether it's AC coupled or DC coupled, more solar. But there will be, once again, some sort of coordination requirements between these devices. Now there's various ways that this is done, but if you are, and for the electricians watching, I haven't drawn any overcurrent protection or isolation. We're just talking really simple single line diagram here. If I add another solar inverter, another solar array to this system, it will need to be managed in some way, because what's going to happen when the battery's full and you're not using any power? How do we stop these trying to continue to charge the batteries? And that's where you have some form of management. The two common ways that that's done is with what's known as frequency. So frequency shift, power control, and that's where the battery inverter actually changes the frequency of the AC output very slightly within about a 1 and 1.5 hertz range, and these respond by reducing their power output. So the battery inverter is commanding via frequency change how much power the solar inverters put out. But the other option is what's known as managed. So managed means there is a communication power control between the battery inverter, which is its job is to protect those batteries. And when you've got a managed system, there'll be a comms cable between the battery inverter and the solar inverters. And it generally is a proprietary solution. So that means that these probably going to be specified as compatible with this inverter over here. So now you're getting into, does that work with this? I better check that first. So Lindy and David, I hope that helped a little bit answer that question. All right, so I'm getting close to the end of today, and I just wanted to finish up a bit with talking about other things to do with going off grid. Now, you'll be surprised to know that having good internet is really important to me. Here I am in lockdown in Melbourne once again, and I can just carry on doing what I do, which is training people because I've got good internet. Now, that's something you really need to consider. When I first went off grid, I didn't even think about it because the internet back in 1991 wasn't much of a thing, but we just had a phone line, and as soon as I got interested in connecting to the internet, I realized a phone line was a pretty terrible choice. So, that may be a very important consideration. Certainly if you're, someone who's doing a tree change and you've, got a business or a very internet dependent family, will you be able to survive off-grid with poor internet services? Now, fortunately, things have got a whole lot better in the interim. Widespread Wi-Fi, so not Wi-Fi, 4G, so you're getting much better services in a lot of rural areas with decent connection. In fact, I'm coming to you right now on Optus 4G, and we get typically 50 to 60 megabits a second. So it's really good speed, actually, better than most people's city-based NBN. We also have satellite here. So Australia launched, I think, 2, maybe 3 SkyMaster satellites. Not sure if the third one's gone up. And that's providing coverage for the whole of Australia for people in remote and regional areas. The difference, though, even though I've got a SkyMaster satellite on my roof, is that it's got high latency. Now, if you're not familiar with latency, that means the delay between when you click on something and something happening. Now, latency is not really an issue if you're streaming content like watching Netflix. Latency is of no significance. But if you're someone who is talking like I am to you and there's someone talking back, that latency can be terrible. It's really hard to have a conversation when you've got to wait for the response to come back. And also, if you're used to using a browser to quickly click on things and move through your work, it's very annoying waiting for that delay. Now, satellite is unavoidable. The latency from satellites that are what they call geostationary, they're something like, tens of thousands of kilometers above the Earth. And so just the speed of light is the limiting factor, how long it takes for a signal to get up there. But things have suddenly got a whole lot more promising. And look, I'm not a sales agent or anything for Elon Musk, but I must admit I just signed up for this service, which is their new low Earth orbit satellite service. Now, if you don't know what that means, it's called Starlink. It's apparently going to be launched in Australia later this year, and it brings the same kind of latency that you have in terrestrial services, like, in the suburbs, 20, 30 millisecond latency to people in remote areas, and also really good throughput. I mean, the numbers that they're stating here have been confirmed by people who've already got it in the US, so 50 to 150 megabits a second. So there you go. It is possible to actually have decent internet in remote parts of the world. So that's coming to Australia soon. Yes, Tradie Trev, Elon has our back. Actually, yeah, there's swings and roundabouts. I'm sure he's going to make a mozza out of it, but it does mean that he's be able to bring internet to something like 40% of the world who don't have any internet. So that's a big plus. So good on him for that. And I see Ray's signed up for Starlink also. Good on you. Yeah, at the moment it's first in, best served. There is limited capacity on those satellites. So, if you're in an area that does have poor reception, you might want to think about that option. Anyway, I'm starting to sound like a sales agent for them. I didn't mean to do that. Lastly, I just wanted to go back to this concept of sharing energy. And I started off saying I'd talk more about it, and that's what I referred to as a microgrid. Now, a microgrid, just bringing this picture up here, is where you have multiple solar and battery storage systems joined together by cables, a grid. It's not the utility grid, though. And what we've got here is 7 homes, you can't see all of them, in relatively close proximity. It's actually difficult to run cables significant distance cheaply, so we're all within about 200 or 300 meters of each other. And there's a central system that provides a stable microgrid to which all the other systems parallel to. Now, this is quite extendable. That means I've started off with just one house and then I've progressively added more and more. What's the benefit? Well, the benefit is that we only have one backup generator that services 7 homes, because if you're off-grid, backup's really important. It means that when there's surplus energy from one house, it actually can flow back to the microgrid and assist to charge the microgrid battery system, which we all share, or even to supply other homes that might be in shade, for instance. So As you can see in this picture at the moment, my house is in sun first thing in the morning, and those panels being cold actually will work quite nicely in wintertime. I could be providing power to the houses in the shade. So it's a way of evening out the mismatch of generation and storage. And it's becoming extremely popular now, certainly on fringe of grid areas. Even the utilities are getting into it as an alternative to running power lines long distances through forests where they can potentially be a fire hazard. So yeah, expect to see more on microgrids popping up. And I'll probably do more coverage on how to build them. I've already done a one Toolbox Tech Talk where I talked a bit about microgrids. I'll probably cover some more of those. But anyway, we've come to the top of the hour. In fact, we've overshot it by about 10 minutes because you've been such a great group. Really enjoyed talking to you today about going off grid. And I think I'll be back with more content around this. So hang on, what's happened to my picture there? Just got to bring that back up. I was going very smooth for a minute then. There you go. So I'll probably bring some more content around going off grid because it is a topic that I love and I get a lot of questions from it. So thanks, everyone. I'll see you next Sunday, same time, 2 o'clock Melbourne time, for another Toolbox Tech Talk. And I've been trying to get a guest in. My guest cancelled on me today. So there you go. Didn't have a guest today, but might get one next week. So thanks, everyone. See you soon.